Hi, and welcome to another episode from Spiral Physics Education. This episode we're going to be looking at something quite specific, and that's practical techniques of measuring speed. We're going to be looking at stopwatch methods and light gates, and we're also going to be looking at how parallax error and precision can also help produce more accurate readings in your practical work. So things that you'll need to know to get the most out of this is everything about speed, instantaneous speed, average speed, how to calculate speed, how to calculate average speed, and also velocity. So if you are comfortable with those, that's great. And if you're not, check out some of the other videos on the channel and they will help you get up to speed, if you pardon the pun, with those terms. So let's have a look at parallax error to start off with. And parallax error is something that comes up a great deal when talking about uncertainties in physics. So here we've got an example where a student is reading the length of a pencil and being asked how could they improve the accuracy of this by reducing the parallax error. So what examiners really want students to say is read at eye level, and that reduces the parallax error, but you might be unsure about what that means. So what that means is at the moment that eye is not at eye level with the pencil, because what it produces is a length that's actually shorter than the true length. It's not an accurate reading at all. So at eye level means the eye has got to move down so that it's level with the top of the pencil, and then it reads across to the scale that way. So that improves the accuracy by reducing parallax error. So we can also reduce parallax error by moving the object and the scale closer together. In this case, we're going to move the pencil closer to the scale. And the closer they are, and even if they overlap, that's even better. That's going to reduce parallax error. So going on to precision, well, there's a lot of discussion about the true meaning of the word precision, but it comes down to the resolution of the instrument being used rather than accuracy. So don't get it confused with accuracy. So the precision of the instrument is the smallest division that it can measure, and it's often used alongside resolution. So resolution and precision are the same thing. So let's have a look at an example with two rulers with different scales. So they both measure centimetres, with the top one clearly each division is a centimetre. And with the bottom one, it's still measuring centimetres, but between each centimetres there are smaller divisions. So if there are smaller divisions, the bottom one is more precise. So we can actually say that the top one has a precision of 1 centimetre, but the bottom one has a precision of 1 millimetre. We could use resolution instead of precision. But using an instrument with a higher precision or resolution will lead to a more accurate result. So let's have a look at then how we can use equipment to measure speed. This comes up quite a lot in physics about measuring speed, average speed and velocity, and also about practical techniques and reducing uncertainty. So that's what we're going to cover here. So in this one, the student is going to use a ruler and a stopwatch to measure the average speed, or calculate the average speed of a trolley moving down the ramp. And what they're going to do is they're going to use the ruler to measure the distance and the stopwatch to measure the time. And it's important whenever you get asked a question about how would you do something in a practical sense, that you pair up the variable that you're measuring with the device that you're going to measure it with. For instance, don't just say measure the length. You've got to say measure the length with a ruler. Don't say measure the time, say measure the time with a stopwatch. Be very specific with what you're going to use. So once you've recorded the distance and the time, it's quite straightforward. You can calculate the average speed by the distance that it travels over the time taken. But that's not, sometimes it's not the end of the story with examination questions. And that they like to talk about uncertainties and how could the student improve the accuracy by reducing the uncertainties. And the thing is that uncertainties are there in every measurement. They're present in every measurement that's taken. And what we can do is we can improve practical techniques to reduce those uncertainties, and we hope that that will improve the accuracy of our readings. So in this practical, we've done 2 readings, length using the ruler and time with a stopwatch. So let's have a look what uncertainties could be there with the ruler. So in measuring length, it's usually down to the position of the ruler, and that causes most of the uncertainties here. So what we can do here is we can move the ruler a little bit closer so that it overlaps with the thing that we're measuring, the distance that the trolley travels. We've got to make sure that we're at eye level, and we hopefully understand what that means now. And we can also use a ruler with millimetre divisions rather than centimetre divisions, because that improves the precision, which will improve the accuracy of the readings. So let's have a look at using the stopwatch and measuring the time. Well, stopwatch is going to be used by a human, so human error is often mentioned here, but examiners don't really like human error because humans make lots of errors. We've got to be very specific about what type of error is here. So try not to use human error in any answers. This is down to reaction time, being able to start and stop the stopwatch accurately, which we're not very good at. So the uncertainties there are reduced by taking repeats. If you repeat it and you produce reliable data, it's very, very close together, then you can take an average, and that improves the accuracy of your reading. And we could also remove the person completely by adding a light gate, and that's what we're going to look at next. So light gates are used a great deal in physics, and that's down to just removing the human aspect of doing the timing. And this is what they look like, and you may have seen something similar in your practical experience. And what you might not be aware of is that there's an invisible beam of light between them. So I've just added it here, and that's usually in the infrared region, so you won't be able to see it. And what happens is, when that beam of light is broken, a data logger that is attached to the light gate starts recording the time. And it's going to be far more accurate in measuring time because humans aren't being involved in recording the time. There's no reaction times involved. So let's have a look at a light gate method for measuring speed. So we're going to look at average speed. And for this one, we're going to use 2 light gates, and we're going to attach them to a data logger. And what's going to happen is that the trolley is going to break the first beam of light and start the stopwatch that's attached to the data logger. And the data logger will record the time until the second light gate is broken. And then that data logger has recorded the time between those 2 light gates. And there's no reaction time involved, so it's going to be far more accurate than just using a stopwatch. In this example, the student still needs to measure the length between the 2, and then they can use the equation average speed is distance between the light gates divided by the time between the light gates. Let's have a look at another method then, and this time we're going to look at calculating instantaneous speed, speed at one position. For this one, we're going to use 1 light gate and a data logger. We're going to add an interrupter card, and the interrupter card is just going to break the beam of light. What we need to do is measure the length of that interrupter card. And this time we're going to input that length into the data logger. The data logger has already been programmed with the equation, and what that equation will do, it will calculate the speed at that point for you. But it's important that we understand how the data logger does that. And that improves the accuracy again, because we're not doing any timing. However, it's not perfectly accurate because we still have to measure the length of the card with a ruler, and that has uncertainties associated with it. But if we do that well, we'll get a far more accurate reading than if we just used a stopwatch. So, I hope you found that useful. Do subscribe to the channel to pick up some more ideas and improve your understanding of physics. And hopefully by the time you do your exams, improve your grades as well. So click on subscribe, and I'll see you next time on Spiral Physics Education.